Hi all. So I'm just going to discuss about the sort of a mock paper today. So of course this has been done because of your requests, and coming to the first question, of course some of the details are given. It's about the room occupancy as well as the water consumption. So if you look at, you can see the room occupancy is given in this figure, water consumption is given here. So according to our question paper, you can also download this question paper from the above link, which is appearing on the the video. And of course I will share this particular document in your WhatsApp groups as well as the emails. So your best representatives will provide you this particular document to you, right? So moving to this part, see, the following information are given with respect of the room occupancy and the usage of the water. So according to the room occupancy, you all know that this is basically a hotel. So that according to the room occupancy, there should be a positive relationship between this water consumption and the room occupancy. So when the room occupancy goes up, the water consumption to be higher. So of course, looking at this particular example, see now time to time there are some fluctuations happening through the period. Let's say from January it was 22 and the February 21. There can be some of the other reasons which determine the room occupancy. So accordingly, if you look at the water consumption has differed from one period to another. So this particular information is given to you. In your question, they are asking to calculate the Pearson's product movement coefficients of correlation for the above data. So how can you calculate this product movement correlation coefficient? Let me show you, right? So first you go here, you want to calculate Pearson's product movement correlation. So how can you get that? You just go here, type equal, right, and then you type Pearson. So you will get this particular equation. Click on that. So what is your array 1? This is the array 1, right? But make sure that you are not selecting this particular titles here in this each of these columns, as well as do not select one of the missing datas, right? The blank cells cannot be selected for this particular calculation because it will otherwise make your calculation wrong. So because of that, select these the related cells and then put comma and then select array 2 and make sure that you are not getting this digit as well because it says blank respective cell here, and then press shift and close your brackets, then hit OK. So you got 0.9636, which is a kind of very positive or highly positive correlation coefficient. So accordingly, you can say there's a positive correlation between the room occupancy and the water consumption, where the room occupancy goes up, the water consumption to be up, and as well as when the room occupancy comes down, the water consumption to be minimal. Right, so this is what we have forecasted. So basically this is what we have taken to see the relationship between the room occupancy and the water consumption. Next question asks us, create a scatter diagram showing the relationship between the room occupancy and the water consumed, right? And also ensure the graph is suitably labeled and shows the lines of best fit. So how can you do this? Create a scatter diagram is not a sort of a difficult task. Of course, you can take it from here. Let me minimize my document. So let's go here. And remember, whenever you do charts, right, you must remember about two things. First one is selection of your axis. The second one is your data. In selecting your axis, you must aware about your x and y axes, meaning that x is the independent variable where the y is the dependent variable. When it comes to y equals to mx plus c types of equations, so y is your dependent variable where the x is your independent variable. So independent variable should be take first. So if you look at remember your room occupancy determines on the water consumption as we look at, right? So because of that, go here, insert, go to the scatter, right? Select it, or else otherwise you can go here, simply select these two cells, room occupancy as well as the water consumption, drag this down together and go here, insert, select the scatter diagram, right? This will give you the dots. Remember, scatter means dots, right? It shows you some sort of a relationship between the data. But of course, like possibly if you see, this shows you a kind of a positive relationship, right? As we look at here, see, we saw this here, meaning that 0.96 showed us a positive relationship between the water consumption and the room occupancy. So I'm going to edit this particular diagram. How can I do it? Just because I need to know what are these details and what are these details. So I'm going to add this chart elements, go to the axis titles, primary horizontal, and then go to axis title, primary vertical. And just take a look at these figures. You can see these things in thousands. So meaning that specifically we have taken this y data because being dependent variables. So we can say these are water consumption in liters. And if you look at this particular part, these are room occupancy, so can be rooms. Okay, now for the moment we can say this is basically the relationship between room occupancy and water consumption. This is what we are showing. Now of course, to show this particular relationship in a line of best fit, how can we get the line of best fit here? So just simply select on this particular graph and go to quick layout. The option appears here, and then go to this third option to show your line of best fit. It shows us a linear relationship between the water consumption and the room occupancy so that you can easily draw this. This is how you should complete your second task at the first question. Then use linear regression analysis to forecast the amount of water that would be used if room occupancy is 24 in the month of January 2022, right? So let's say in January 22, if you got room occupancy of 24 rooms, so what will be your consumption? So this is what they're asking. If you look at how can you do this in Excel, right? Simply go here. So you're going to forecast water consumption in January 2022, right? So let's say we're going to get the consumption here. Select this cell, press equal sign as you are going to include a kind of equation. So press you just type forecast because this will allow you to calculate these things. So your node X or the independent variable is 24. You know about the room occupancy, and press comma. Your known Y's are these things, your dependent variables. Your known Y's, do not select this blank cell. Press comma, then come to known X's. So you know about these occupancies, right? Select and press close parenthesis, then press enter. It will give you a figure of 1256.53 liters, right? So rounding off to 1257 is the number of liters that you are expecting to be consumed in January 2022. Okay. The next question. With reference to the Pearson product movement coefficient of correlation, comment on the validity of your forecast made in part C. So what is this? Simply, product movement correlation showed us the water consumption as well as the room occupancy is having a kind of a positive relationship, which is highly positive because that was around 0.9. So when it comes to part C also, we see that we can show this saying that the room occupancy in January that has went to 24 numbers. So accordingly, the consumption has come down from December. See, December there was 58 rooms and water consumption was so high, 1596. Now if you look at the nearest figures are kind of to this figure is 1256. Let's say 1250, 1260, or maybe 1200, right? So you can say accordingly, you can see there's a positive relationship which comes with, when the room occupancy is high, the consumption is also to be high. The room occupancy is low, the consumption is also to be low. So this is what you can see from this particular C's answer, and if you look at the correlation coefficient. Okay. Now if you look at next question, identify two other factors that might impact upon the accuracy of the forecast. So this can be because we don't know whether the people, the visitors, those who are coming, or the guests, those who are coming to the rooms are always going to use the water, or else there can be some of the persons that they are using them as a change in rooms, so where they're not going to use the water or something, or maybe the people, those who are coming for a small rest, they're not going to use the washrooms so far. So these are the possible reasons that I have showed to you, right? These are not the exact reasons because there can be some of the other problems as well, right? Or maybe due to a sort of a water cut, the consumption would be minimal in some cases, right? There are positive consequences. Right, going to the second part, of course, we have following are the figures of wine sales of RRR liquor franchise for 4 years period. So if you look at 2016, 17, 2018 and 19 is given. The sales figures are given under the quarter basis for your reference. The figures are given in bottles. Remember, these are not sales figures, these are given in the bottles. Now if these are given in the thousands or maybe in turnover figures, you have to calculate all your information, whatever you will receive just after your calculations, into thousands to get the accurate figures, right? Let me show that hint. Right, so then coming to sales in bottles, if you look at 2016, we had in first quarter, that is 75, second quarter 53, third quarter 68, fourth quarter 70, and so on and so forth. So then coming to our Excel, of course, I can show that to you in my question number 2, so which I have already imported some of the data here for my calculations, right? And of course, if you looked at here, you can say 2016, 17, 18, 19 is given, and all the quarters are given here, and sales figures are shown here in bottles. Now, looking at our first question that will ask us, plot a histogram to display the above data. Go here, select on a blank cell, just go to insert, select on here, and just take a empty graph. Then simply click right on this. Then after, right click on this, just go to select data, and then go to add. Series name is cells, and series values are like this. Hit OK. But still, you can't see any of the time durations, or maybe let's say that is not given in quarters. If you look at these are sales figures, that is fine, but still you can't see because you can't see the quarters are given here. It just says 1, 2, 3 and 4. Because of that, to revise it, you need to go to add again, or maybe you can go to edit, axis label range is Y to Q to drag it down up to here. hit OK. So then you will get OK, then you will get the quarters 2016, 17, 18, 19, like this. But remember, you made a mistake here. What is it? Because if you look at this Y and Q are mentioned here, so it is wrong. So what you can do is go to select data, click on this, edit, click on this value, backspace, select this 2016 1 and come down, then press OK. So that clearly shows you 2016, 17, 18 and 19 data are given here. Right. Okay. So then this is our chart, but remember this is our line chart. But remember, when you comes to the add chart elements, remember to add all these primary horizontal and primary vertical axis titles, otherwise your chart is going to be incorrect or inaccurate. Right, so these are basically the sales figures. So let me rename the sales in bottles, and then these are years and quarters. Right, now the first page is finished. So then refer, perform a time series analysis to estimate the number of bottles that might be sold in each quarter in 2020, so which is the forthcoming year. So we are going to do a forecasting again, but remember this is not kind of a linear forecasting, so we need smoothing as well as central moving average functions to be done to calculate this particular 2020 figures. Right, so I will show you how to do it, but before that we are going to do a sort of a calculations here. How can you do it? Right, so coming to the moving averages, this refers to moving average and central moving average and seasonal variances. Remember, let me get this down here. Right, so I'm going to show you how to do this. Simply coming to the moving average, how can you calculate the moving average? Just go to the cell number 2, right? So you are working on a quarters, right? Remember, you have to take all these 4 quarters to your first year, right? So you are going to make a kind of a forecast, and that is the purpose of calculating these moving averages and central moving averages and seasonal variances. So because of that, you must remember you cannot start from the first cell. So you come here to the second cell and select your whole year like this. So you're going to calculate the averages of these moving, the sales figures. So press average, right, type average and get this particular equation. Select it from here, drag it down here. So then hit close the parenthesis and hit OK. So you get this figure. You can continue by this particular figures by double clicking here, just double click here, but you will get the unwanted information here, so that you can simply delete all these things. And make sure, if you look at 2019, the 4th quarter, see whether there are 4 cells, because we have initially selected 4 cells here. So we've got the average of 4 cells together. So go here and see whether they have selected 4. Yes, they have selected, but remember there are 2 empty figures as well. So we don't want this. So because of that, we are going to delete this final figure. Select this and see whether we have selected any of the nulls. Yes, there's one you can see empty cell included, so that we are going to delete this as well. And if you look at this one, okay, it's fully occupied, so we can see 4 figures are given. So we are going to use it. So then go to the third column accordingly, third row accordingly, sorry. Then just go to you're going to calculate the central moving averages, meaning that the moving average of these figures or the average of these 2 figures, right? So by selecting this also, you can see here that is the average of 66.87. So you are going to calculate the central moving average here. Just go here, select this third cell, get the average of these two, right, only these two, then close the parenthesis, hit OK, right, and then just drag this down up to here and see whether you have selected the two cells. Yes, you have selected qualified two cells here, so just let it be like that. And then you're going to calculate the seasonal variance, right? How can you calculate the seasonal variance? Simply you can do, just come here. Seasonal variance means the difference between the sales and the CMA, so that the central moving average. So you can just press equal and then select this particular sales figure and just deduct CMA figure from that and get this one, and accordingly you can drag this down and you can get the rest of the things, right? I'm very sure that you will see some of the figures are automatically came here because I have already formulated and formatted all these cells to get all these figures, right? That is for the reference purposes. So but I'm just telling you, right, then just after this what you will have to do is, because you are doing all these calculations to calculate the figures of 2020 which you are going to forecast about, and because of that my recommendation is for you all to write these all seasonal variance figures with respect of their years. If you look at, these are 2016, 2017, 2018 and 2020. 2019, and we are going to calculate the 2020, so I'm not going to put it here, right? So then if you look at in Excel, it is very easy to calculate all these things, right? Remember, these are seasonal variances. Let me seasonal variance, right? So that these are my seasonal variances. If you look at 2016, that is quarter number 3, I had 1.125. So accordingly 2016, this is my quarter number 3, so 1.125. Or else you can simply select this cell. And in my fourth quarter I have 2.37, so that just go here and select this one, 2.37, and then accordingly you can select all these things. See, I have selected G9, meaning that this cell, and so forth, right? So then what are we going to do? So you have to take the sum of all these figures, meaning that out of all these quarters you will have to do a kind of a trend analysis. So you have to find out the trend component, right? So simply what can you do is you just sum them up, add them all together, and you will get the sum. Let me add this. I'm just putting an equation, equal sum, open the parenthesis, select all these four figures. Actually in the class we did these things kind of manually, and I showed you some of the areas of doing, but we didn't do these types of calculations, right? And just click on the sum and just get this figure, right? Don't worry about this figure, I will show you how to get this, right? Let me delete this first and I will show you. Then after you got this figure, make sure that always you are getting the correct figures, right? Because there can be pluses or minuses, right? Remember, so better you put this sum equation and get all these figures. Then after you drag this here, so you will get the rest of the sums like this. Doesn't matter whether the cells are empty, you just add them up and make sure there are no any ghost figures, maybe the figures you can't see just because of the font color whatsoever, and ensure that only 3 figures are added together. Then we are going to calculate the average seasonal variances. How can we do that? Because we have 3 figures here, so I will To get the average, I will divide this figure from 3. So I got 9.4 here. I will get the figure divided by 3 minus 12.33. So accordingly, I will get the rest of the figures like this. Divided by 3, divided by 3. So I got all these figures. Now, let me calculate my forecasted figures. How can I calculate? Now, when it comes to manual calculations, though, we have to find the extended trend. But when it comes to Excel, it is very easy to calculate. Where you can do, when it comes to this, of course, you can go to the cells. Just drag it, highlight all these cells. Then just come here and drag it down here. So you will get the rest of the figures to come here. See, this is the trend component, right? This is the trend, which is almost like continued, right? So that we are expecting this much of a sale during the next year, right? So I'm going to calculate my forecast figures, right? This is basically the extended trend, right? What we are doing is actually we are continuing with this trend, of course, by dragging this down. See, so then after I'm going to work on my figures when it comes to, let me take this here. So then after I'm going to copy these figures to here, copied, and sales in bottles. I got all these figures here. Let me reduce the number of decimal places because we are not having any of the decimals, right? But for the moment I will keep one here, right? So that I'm going to get my forecasted figures by doing what? Simply I will get all these average seasonal variances here. Let me show you ASV, and let me extend my table, and this is my ASV, and these are my forecast sales, right? So that I will extend my one. Yeah, so I'm done. So I'm going to add all these here simply by putting equal sign, select this. By putting equal sign, select this. I'm done. Then I'm going to simply add all these together so that you will get the forecasted sales. To add this one to this, accordingly I will continue. So these are my kind of forecasted sale figures, forecasted sales. These are my forecasted figures with 2021. So I can say my sales figures are going to be 75.6, so almost like 76, 54, 66 and 70, which are rounded off. So these are the figures that I'm going to get if you look at, right? Okay, so this is how we can do it. So simply when it comes to my chart, of course, when it comes to my graph actually, so we missed a part to do. See, performer time series analysis actually we did, and we forecasted on the figures to become on 2020, as well as if you looked at plot the trend using a centered moving average onto the histogram. So to do that, central moving average, so we have CMA here, the figure is given. So simply go here, right click on the graph and just go to select data, right, and you're going to add another set of things here. So you're going to add series name is CMA and your values are, remember to drag it from here, select it from here and just take this back in this way. I'm really sorry about the noises coming through out my surrounding. So just forget about them, right? Select it from here and just drag it from here. Remember, right? Because you have to select this line from the beginning, right? So you have to select all these together up to the fourth quarter that you have done your calculations based on. 2019 fourth quarter only we got all the data, and we have 2020 we have the forecast figures. So I'm going to stop it from here and then hit OK. So this is what you call as the trend line. Okay, remember you will have to press OK and then come here and select this. Remember to go to the design and add chart element and say legend to be at the right, so that cells and CMA is not the correct word for this, so I'm going to edit it. I'm going to say this is actually my trend line, so that let me see. Okay, so that shows you the cells and the trend line, which is very easy, right? And then thirdly only you will have to calculate all these things. Then identify and explain the two reasons why the wine seller might question about the accuracy of their forecast figures, because the forecasts are always going to be the forecasts. Remember, these are not the accurate figures, and also based on some of the figures we can't exactly forecast. Now, as an example, even if you are going to calculate all these things and you are getting that is why I have just showed you 2020, right? If you looked at in 2020, actually we couldn't forecast any of the things because, you know, due to the pandemic situations, we had to face different types of sales fluctuations and maybe loss of sales and lots of problems. So because of that, all these accurate the figures are not going to be accurate during the years. So these are the problems that are associated with the forecasting. So that is the explanation. Even though we did this calculation in the last class, of course I got to know some of the people are having some concerns, as well as some of the people couldn't understand this. So because of that, I am going to explain about the index calculation as well. So how can you calculate the indexes? Now, if you look at the month is given here, average consumption expenditure is given here, and the consumer price index is given here. Now I'm going to calculate the average consumption. For the average consumption expenditure, I'm going to calculate the consumption expenditure index. Right, this is what I'm going to calculate, so that I will take it here. Right, and for this actually the question asks me to get 2020 of January as the base period. So if I look here, so this is actually 2020 January, so this is my base period, and I'm going to calculate this by putting my Excel here. I'm going to format my cells into, just try and select these things, and I'm going to press on this to convert them to a percentile style. Now these are percentiles. If I type 2, that will be 2%. See, that is how it comes. So because of that, I'm going to delete it. I'm going to calculate this one by putting this. Simply a fraction, average consumption expenditure divided by itself, going to be my answer. I'm extremely sorry. Yeah, and I'm going to hit here 1760, divided by, my base period is 1725, so I'm going to work on that, and I'm going to constantly fix this figure. My 1725 is not going to be changed, so that I'm going to press F4 to make it constant. I'm going to drag this up and drag this down, so I will get C7 divided by C5, C8 divided by C5, C9 divided by C5. All these are cells, so I've got 111 finally, right? If you look at, even though the consumer price index says that is like 100%, 100.3%, 100.8%, 101%, 101%, and so on and so forth, but still you can see a huge sort of a variance from consumer price index to consumption expenditure index. But consumption expenditure index shows you kind of a huge figure, a huge variance out of this. You can see 100%, 102, 104. There's an inflation in this particular series, so you can see it, right? This is how we are going to show you the calculation of indexes. So I'm sure that you are clear with the computations, and I wish you all the very best for your examinations. Thank you very much.